thumbs sideways if it was okay, kind of hard. Thumbs down if you didn't do it at all.
Oh.
And I know who didn't do it at all. Perfect. It was easy but really repetitive. I know. It's one of those things like, you remember in elementary school when you did like multiplication charts? It's really repetitive.
I tried doing.
But what's 4 times 12?
48.
4 times 12?
48.
48. Okay, maybe it wasn't as helpful as I thought. But I was going to say, it's repetitive and annoying, but you remember it, right? So that was kind of the point. Now, we're going into some less concrete things today, more abstract, and just understanding, right? Understanding a function. We're going to see some funky looking graphs, like this one right here. All right? And this graph represents a plane's flight pattern. Anyone ever been on a plane before? Yeah? Anybody ever fly further than like 2 hours? A couple people? 16 hours?
I drove 8 hours
To where?
19 hours.
Oh my God, 19 hours to where?
From New York to New York.
Wow, that's far. Tyler? Tyler?
Why is the plane flight like over 5 days?
Oh, you're talking
Okay,
about
hold on, we'll talk about it, Tyler. I know what you're talking about. Just give me a second.
Oh, you're talking about plane flights.
So, most of us have been on a plane. If you haven't been on a plane, you know how planes work, right? They're on the ground, they go up in the air, they go down, they land on the ground. Okay? It's just understanding. We're understanding, right? That's how planes work. Please stop. What do the x and the y axis represent? What does the x axis represent here? Time in hours. Obviously, it's not hours, right, Tyler? What should it be? Time in what?
Minutes.
Thank you. Okay. I'm not perfect. Okay, time in minutes, right? Obviously, it's not a 180-hour flight. Okay. What does the y-axis represent, Tyler?
Oh, feet, but I don't think that's correct either.
Of course, it's not correct, Tyler. Why would it be correct? Why would I do anything right? It's the altitude in hundreds of feet.
How do you spell altitude?
It's literally right there.
Altitude, hundreds of feet. So up here would be 2,400 or 24,000 feet. I don't know. It doesn't matter, okay? The height doesn't matter. Pretend it's a toy plane. It's not actually flying high. All right? You can make the numbers whatever you want in your head. We're just using this to understand why the graph is shaped like this. We're used to seeing graphs of lines nice and straight, maybe even a U-shaped graph. Anyone remember what we call a U-shaped graph? Starts with a P. Close. It looks like a parentheses, kind of. Do you guys know what I'm talking about? You guys learned this, no? Did you guys learn this last year? There you
My
go.
little sister's friend.
Not a paragraph. Parabola. Okay, everybody listen up. Everybody say parabola. Parabola. Not parabola. Parabola. Okay? We'll learn about this more this year. If you've seen it before, great. If not, it's okay. But the point of me bringing that up is some of these graphs are going to look a little bit funky, all right? This one is very tame compared to what we're about to look at. So let's understand what's going on here. We know that the time is the x-axis. So as we move to the right on the x-axis, what is happening?
It goes up.
Just don't even look at the altitude. What's happening as we go to the right? The numbers are getting bigger, which means that time is what? Passing. Okay, again, we're starting with the basics. As we move down the x-axis, time is passing. Right? The y-axis represents the altitude. So as we go up the y-axis, what's happening to the altitude? It's going higher. It's increasing. All right? So at 0 hours, which is right, I'll do this in a different color. Right here. Right? Where is the plane? At 0, 0. In the context of the world, where is the plane? Yeah, you're all right. It's on the ground. Because the altitude is how many feet? 0 feet. So after 0 minutes of flying, the plane is at 0 feet. Right? That makes sense.
Would it be at sea level?
Sure. Why not? Now, section A of the graph, I'm going to do in orange. I'm going to do a little orange line right there. There's section A, yes?
Yes.
Who could tell me with a hand what is happening in section A, Christian? Time is going by and the plane is going up. Absolutely. You could write that. I'm going to say the plane is ascending. What does it mean to ascend? Go up. The plane is ascending as time passes. It's a nice little succinct summary of what's happening. Yeah.
What does question 10 say?
We are on question 3. Question 4.
Question 10 is like
Where is the plane?
We will get to question 10. All right, we're on question 4. Question 4 says, what is happening in section B? I'm going to do section B in blue. B for blue. Boom, there it is. Who can tell me with a hand what's happening in section B? Yeah.
It is at its peak height and it reached statement.
Good. It reached its peak height and it's staying there. Is time still moving?
Yes.
Yeah. Is the plane ascending anymore?
No.
No. So what's happening in section B? The plane, we could say, reached its max altitude. You could put this in your own words if you want, right? We're just understanding. There's not necessarily a 100% right, 100% wrong answer. The plane reached its max altitude and stayed at that altitude, or something along those lines.
What if it's a paper airplane?
Well, if it's a paper airplane, it'll still ascend and then stay, and then we'll see what's going to happen next. Obviously, we know what's going to happen next. All right, everybody got number 4 written down
Wait.
in their own words or in mine? I don't really care. Who can tell me with a hand what's happening in section C? Alex, what's happening in section C?
The plane is starting to descend.
Hold on. Alex, what is happening in section C?
The plane is starting to descend to the ground as we make our final stop.
Perfect. I love the way you said that. That's right. The plane is descending back to where? The ground. We end at what altitude? 0. What does it mean to have an altitude of 0? We're on the ground, right? You may be thinking, this is so dumb, Mr. Church. Obviously, this makes so much sense. If it makes a lot of sense, then you're in good shape. The plane's descending. Back to the ground. What does it mean to descend?
Go down.
Yep, that's right. Back to the ground. So we're just understanding, right? The first section of the graph, section A, we're ascending. Time is moving. The altitude is ascending, right? Going up. Then there's a portion of time where the altitude doesn't change, right? It's called a cruising altitude. What can you do on a plane, for those of you who've been on a plane once you've reached cruising altitude? Walk around, go to the bathroom. They bring out the little snack cart, right? If the plane is going up like this, right, you're not going to be walking around. You got to wait till it's nice and leveled out. Tyler, you have a question?
Why is it like finding at a really slow rate?
Okay, we're just going to keep moving forward. Number 6 says, what altitude did the plane reach after just 30 minutes? How can I figure out the answer to that?
The graph.
Look at the graph. Anthony, where am I going to look on the graph?
The x-axis.
Okay, where on the x-axis specifically?
30 minutes.
30 minutes. Perfect. We're going to look at 30 minutes.
And then look up.
We're going to look up until we reach what?
120.
The line.
The A.
Right, Davis?
Corner.
The A.
The line right here.
Yeah, the dot.
So we go to 30 minutes, we look up, we hit that line, then where do we look?
To the left.
To the left, to the y-axis. Where do we hit on the y-axis?
120.
120. So yes, I know the plane is much higher than 120 feet. We're just going to say 120 feet, okay? Because that's what the graph says. And yes, I messed up the graph, okay? I'm sorry. It's fine. 120 feet. This is just practice understanding the graph.
This is really basic math.
What was the highest altitude the plane reached during the flight? Who could tell me? Yeah, Ava.
240 feet.
240 feet. Where did you find 240 feet?
Yeah, on the ground.
On the graph? Where specifically on the graph?
Why?
Yeah, section B.
Section B. Good. And we looked over to the y-axis. Right? So this graph line here in all its different colors, does it ever go higher than section B? No. So that's the max altitude, right? 240 feet. Again, I know that doesn't make sense logically.
feet.
240 miles.
240. Even then, 240 miles would be so far out in space. I think to the ozone, it's only like 12 miles or something like that.
200.
I know it sounds weird.
2.4.
We are 12
I
miles.
wanna
Because
go
the
back to
thing about the crust, we're not going to get into a science lesson, but the crust is so thin,
Yeah.
right, that the distance between our Earth and the ozone is not as far as you would think. It's only a couple miles. Because most of the Earth is the inside part. Again, I'm not a science teacher. We're not going to talk about this.
I am.
Number 8 says, how long did the plane maintain a constant altitude? Who can help me find that answer, Colby?
90 minutes because when you look at section B from 16 to 120, subtract that by, I mean,
You got the right idea. It's not 90, though. What is it? 60, yeah. But you got the exact right idea. Section B is where we reached a constant altitude, right? So 60 minutes into the flight, we leveled out. You can walk about the cabin, use the bathroom, all that stuff. It stayed at that altitude for an hour, and then it started going back down. So this right here, there's my constant altitude. How long did it last? 60 minutes, right? Great job, Colby. Thank you. Yes, 60 minutes, not 60 hours. Who can tell me how long the entire flight was? Yeah, Gurpreet? 180 minutes, exactly.
Yeah. I think the farthest flight I ever been on was like a couple minutes.
A couple minutes?
Yeah.
It's a short flight.
The farthest I ever flew is probably like Vegas to Cali.
Oh, that's short. That's super short. That's like 45 minutes. Now, number 10, great question, Leon. Number 10 says, where is the plane after 3 hours? I apologize for the printing. Judah, where's the plane? The ground, right? Because what's the altitude after 3 hours? 0. 0. Okay? So where's the plane after 3 hours? Ground.
Bro, you're not eating.
Back on the ground, safe and sound. Right? Yeah. Okay. Ooh, not about that right now. We're learning a new lesson. I don't care about the test right now. Okay, here's what you're about to get right now. Are you guys listening? Yes, we're listening. Okay, I want this. Okay, Aaron, face forward. So you're gonna get this glued in. It's basically the same idea of what we just talked about, just with a little bit more funky graphs going on. And you're gonna work with the person next to you or the people behind you, and see if you can figure this out. All right, and then in 5 minutes, 5 minutes, okay, we're going to talk about it together. I'm going to give you 5 minutes to explore this with each other, see how you can do it.
Anthony's. You have to get the other one to
Anthony, why did you drop that down? Anthony, that's not very rich. I'm sorry.
And the printing is still bad.
The printer is dead.
It's just not good.
Stop touching me.
Okay, are you guys okay? Okay. Okay, listen up. The very first part of it is probably printed poorly. Take a look up top. You can read it on my screen, okay? So we're going to take 5 minutes. 5 minutes to see if you can go through this together and figure out these questions. All right? Go ahead. You're in a group of 3. Work all 3 of you together.
See why I've been like you a little nonsense on my student. Get out. Like with Cody. You only allowed to come back to my
I don't know
studio on
what they
Sunday.
by them invite them to do it, so I'm not gonna go.
Yes, actually.
I just put you in join. Yeah, she's
We
driving.
do closed sessions.
Guys, we're my segment 6 says. Oh my god.
Playboy says, you see, already got that face on, so I said not allowed. And 6ix9ine got banned last week. Wait till I need to let her come back to Sunday.
Here you go.
They told me to stop banning too, because they say you're going to pick some people we call eliminate days.
From the warehouse. But isn't this the warehouse because and this is wait. Yeah. And then this it starts that's somewhere completely
Oh my god, bro. Oh my god, bro. I'm gonna crash out.
Yeah, he said.
You look like Nelly smiling.
I'm gonna write that right now.
What you say after? What you say? You like say something? Be in the south.
So each of the segments,
You said I'm so bored.
right? So this is from the.
I like
Yes, exactly. 8 a.m. 5 p.m. That's right.
come back until Sunday.
That's how far it goes, and that's how long it takes.
And because this is a short room, it takes
But here's the thing, that only takes a longer amount of time to go back to the time.
maybe because he has to go to different routes.
I think you're allowed to come back and then you can have a.
No, that's your work shift.
If we get him on, I'm just gonna write the answer.
Hey!
The distance to get on top of
What is that water bottle?
I think finally dropped off the piece of play or too long ago.
What is this segment? Is it H2O7? Or does it mean two?
What you say?
H2O2.
Is
I'm not drinking hydrogen.
I think he finally got his own water bottle.
I've been having my own.
I think he learned it.
Yeah, I think it learned because stop grabbing people. You know what it does stop touching people pockets.
This is why you never touch anybody's
Hope you know.
Yes. Going back to where they came from, the warehouse.
It's already.
Because at 5. Don't hold my hand, man. You're weird.
Stop pointing your spray bottle like this.
I said you should have taken that. You
But is it
Too
this?
low on the.
How about leave that?
that down. Need your help.
Maybe two and eight. Mine's 10 minutes.
Nah, it's fine.
Look at 2 and 8. But it wants to.
I think he takes
Yep.
So you still reading it, but it's like it's not.
Where are we?
Okay. We're about to explain right now. Are you having trouble figuring out too, Davis?
There's no numbers on the graph.
Okay, real quick, what is it?
Why do you say number 7?
Yeah, there should be no 8, 9, 10, 12. Wait, 5, 6, 7. Oh yeah, it should be 8, 9, 10, 11, whatever. Put 17 or something. I'll know what it is. I'll know what it is. Perfect. Works for me. All right, let's come together and take a look. Okay, you guys are going to help me out here. Okay, not as simple of a graph as the plain one, obviously, but we can still analyze what's going on, okay? So it says the distance a delivery van is from the warehouse varies throughout the day, all right? So my y-axis represents what? Y-axis, what does it represent? Distance in miles from the warehouse, right? Okay. So where do we start on this graph? At the warehouse, right? My distance from the warehouse is at 0 when my shift starts. What time does my shift start? 8 o'clock. Okay, and when does my shift end? 5 p.m. All right, so my y-axis goes from 8. Sorry, my x-axis goes from 8 to 5. Okay, technically we should say from 8 to 17. Right, military time. Because 5 is less than 8, that wouldn't make sense for them to be on the graph, right? So 8 o'clock, or 0800 to 1700. Okay? So we see basically just general understanding, right? We start at the warehouse, we're going away from the warehouse, we're going away. Looks like we stopped a little bit, now we're going further away, we stop. Then we're coming back towards the warehouse, we stop. We come back towards the warehouse for a long time, and then all the way back, boom, we end back at the warehouse, right? Basically what's happening, just like the plane, except it's not as clear cut as we saw before. So, segment 1. Where's segment 1? I'm going to do segment 1 in orange. Segment 1 shows that the delivery van moves away from the warehouse. Okay. What does segment 2 show? Can someone with a hand tell me what does segment 2 show? Liana.
Why you raise your hand?
I was kind of just like stretching and you like called on me.
Okay, inopportune stretching time. That's fine. Alex?
The distance is increasing from the warehouse as time passes.
Good. So, are you saying that's for segment 1 or segment 2?
Segment 2.
Okay. You're not wrong. You're absolutely right. Again, there's not a specific answer to this, right? What is the difference between segment 1 and segment 2? It might be a better question.
Oh.
It changes slope, right? What does the slope here represent?
Time.
Speed, right? Like Gurpreet said. My line is nice and straight, right? And then it gets a little bit flatter in section 2. That means that we're still moving away from the warehouse, but we're doing it slower, right? Because we've covered less distance in the same amount of time. Does that kind of make sense?
Yes.
Again, it's the relationship between time and distance. So what does segment 2 shows? Still going away from the warehouse. I know there's not a whole lot of space to write. But going slower, we could say. Or whatever you wrote that's along those lines, I'm sure is fine as well. It doesn't have to be exactly what I said. Part B says, based on the time frame, what change in the distance from the warehouse is represented by segment 6? All right, where's segment 6? I'm going to look for segment 6. Here's segment 6. What change in the distance from the warehouse is represented by that line? Melanie,
No, this.
is there more spiders?
My shoe, 'cause
What's
gum
happening?
got on my shoe 'cause there's gum under the chair.
Okay.
Uh-oh.
Rest in peace.
Are you able to break it off?
I don't want to touch it.
Grab a damn towel.
Okay, we'll
Towel.
I
If you need, you can. If you need to get it off your shoe, you can step outside. You got it. Yeah, that's fine. Liana. Okay, let's recenter our focus, please. What's up, Liana? Perfect. Help us out, Liana.
The warehouse represented by segment 6 shows that the driver was moving farther from the warehouse, but then you started getting closer.
Good. Segment 6 shows we're going back towards the warehouse, right? Beautifully said. Anthony, you got a question?
No, I was gonna answer.
Oh, perfect. Maybe you could help us out with the next one. Next one. So for B, what's happening in segment 6? Going back towards the warehouse. Nice and simple. Going back towards
Yeah, I'm definitely gonna
warehouse.
warehouse.
Anthony, you got the answer to number C? Which line segment shows intervals where the distance did not change?
Number 5.
Perfect. Number 5, definitely. Is there any other?
Yes.
Yeah. What else shows that we didn't change distance at all, Anthony?
And number 7.
Perfect. Thank you, Anthony. Number 3 and number 7. How can we tell that the distance didn't change there?
Because they were flat. It's a flat.
Because it's flat, right? Just like the airplane.
Because number 2 is also flat, but it's not like. It's
Yeah.
still moving. It's moving toward.
Exactly. No, you're absolutely right. It's getting flatter, but it's not perfectly flat, right? So we are moving away, but like we said in part A, we're moving slower, okay? Number 3, number 5, and number 7. Well, let's figure out why 3, 5, and 7 are flat. Anyone got a possible explanation, Colby?
Maybe like took more time to like deliver stuff.
Took more time to deliver? Okay, Tia, what were you going to say?
I've been
They
turning
stopped
my
to make a...
into M's on accident. All my M's into N's on accident.
Hold on. To make a what? Bathroom break. Sure. What else?
Stop to make a bathroom break or traffic.
Okay. Yep. They stopped in traffic. They stopped to make a bathroom break. Tyler?
Delivery.
Delivery. They stopped to make a delivery. Liana?
He went on break.
He went on break. Perfect. All of those are great. Any one of those is fine. You can write your favorite one. I'm not going to write anything. If you want to come up with your own fun, I don't care. That's fine.
Oh, the truck needed to go to school, so then that's why he didn't.
Well, he stopped where he was at. He didn't go somewhere else, right? He stopped.
Yeah. But
That
Okay.
Taco Bell didn't sit right.
Taco Bell didn't sit right. That's a possibility, too.
segment 4 and 9.
I have notes.
Unreal.
So, number 1. Let's move down here to this next part. This is still in pertaining to the delivery problem, right? It says, explain how the slope of each segment of the graph is related to whether the delivery truck is not moving, is moving away from, or is moving toward the warehouse. This is a great question, right? We have 3 different types of slopes on this graph. Each little continuous segment has its own slope, right? What are the 3 types of slopes that you see here? I'm not looking for a number. I'm looking for a type of slope. Tyler, what's one of them?
Going up.
Okay, what type of slope is going up?
Number.
Okay,
No, that's not the truck.
Oh, which one? Oh, this one.
so you're talking about like look at line segment number 1, right? Let's just say it has a slope of like, I don't know, 4. Okay, it doesn't really matter, right? What type? Maybe I'm not asking it the right way. Does anyone know what I'm talking about or no?
Ascending slope?
Ascending, good, which means the slope is
Rising.
rising, which means it's positive.
Oh.
Okay? Maybe I wasn't asking it very
I was
well.
thinking too hard about that.
So if we're moving away from the warehouse, what type of slope do I have?
Rising.
Positive. Positive slope, right? A rising slope doesn't make much sense, but a positive slope, I know what that looks like. A positive slope is any line that's sloping uphill from left to right. That would be a positive slope. Okay?
Oh, I see.
If I have a horizontal line, what's the slope of a horizontal line?
Same.
Equal.
Nope. What's the slope of a horizontal line?
Flat.
It's the same number for every horizontal line.
Zero.
0.
Yeah.
There we go. Did you say 0? I'm sorry. There's a lot of people saying a bunch of things. If you said 0, you were right. This has the slope of 0, right? Because if I'm right here, I'm going to rise 0 and run 4. 0 over 4 makes 0, right? We remember slope, right?
Yeah.
That's our next unit. That'll be fun.
Oh, I forgot.
So if we stop moving,
Yeah.
I have a slope of
0.
0. I'm going to say 0 slope. And if I'm traveling back to the warehouse at the end of the day, what type of slope would I have now?
Negative.
There we go. Perfect. Back to the warehouse, we've got a negative slope. Because the y-axis is measuring the distance away from the warehouse. This is where we actually have to think a little bit harder. Back to the warehouse, we got a negative slope. Right?
Yeah.
Because our distance from the warehouse is getting smaller and smaller as we get closer. Okay? This next little section, this is a good one. Did you guys get a chance to get down to this one with your groups?
No.
Perfect. If not, that's okay. We're just going to talk about it. Actually, take 2 minutes. See if you can figure out at least a first couple of questions here. Take 2 minutes.
I'm done.
Because you guys learn more from each other than you learn from me anyway.
I'm done.
I would give each one a score and one last.
People are leaving. People are
Is that okay?
Yeah, but that's the end of the day.
Oh, okay. I thought you were some of the apartment. I was like, that's kind of crazy.
Yeah, remember?
I'll take a look at it when we leave.
That cup in blank amount.
Davis, let's not lie down.
What is we
Maybe we should beat her.
What beat you?
I was complimenting you. I said you were the coolest kid in the world. You should have said
It's asking to explain how the slope is related. So it has to be a positive slope, 0 slope.
No people
If you understand what that means, you know it's the sentence. So if you get what it means, you can correct later and understand it. That's fine.
Yeah.
Davis, don't start. Go to read Shut up.
That's crazy.
Oh, I have to. It's okay, guys.
What is a positive?
All right.
Look at all your teachers.
Mm.
I'm gonna do that with my
All right, let's take a look. Let's just go over this. I saw a lot of you guys got most of it done. So this graph now shows the attendance at a hockey game. Anyone ever been to a hockey game before?
No.
Some of us. Was it a Golden Knights game? No?
San Jose Sharks.
Oh, okay. San Jose Sharks.
That's my favorite hockey team.
There you go. Has anyone ever been to a basketball game? Like an NBA game? Kings game, hopefully? Yeah? What about a football game? Okay. What about what other sports are there?
Baseball.
Soccer? Baseball? Okay. So if you've ever been to a professional sporting event, raise your hand real quick. Or any sporting event. Could be high school, anything. Okay. If you haven't, that's totally fine. Again, this is one of those things where we can just understand it without having the own, let's stop holding hands, without having the personal experience, okay? You guys ready? So, what does my x-axis represent?
The time.
Time in minutes. What does my y-axis represent? Number of people. Okay. So just looking at this part of the graph, what is happening as time is going by?
There's more people.
There's more people arriving at the game, right? So segments 1 and 2, what do they represent?
Like this.
Liana, what do they represent?
They represent that's when the majority of people showed up to the game. And can I use the bathroom, please?
Sure. Most of the people showing up for the game.
I'm gonna just take that off your hands.
All right? Segment 8. Where's segment 8? All the way over here. Who can tell me with a hand what does segment 8 represent? Chloe? People leaving the game, obviously, because the number of people is decreasing dramatically. People leaving the game.
18 probably got
All right? What's happening in segments 5 and 7? Who can help me out with that? Tia? Nobody came or left. The amount of people stayed the same. Amount of people stayed, I'm going to say constant. That just means the same. Right? Nobody came in. Nobody left. Who can help me out with segment 6? What does segment 6 tell us, Tyler?
People are losing interest in the game, and then they're leaving.
And then they're leaving, right? Couple people left. We could just say couple people left early. Beating the traffic. That's right. Or their favorite team is losing.
Yeah.
Right? I'm sure there were Jets fans in San Francisco that left early yesterday because their team was losing pretty bad. What's that?
What was section 3? Oh, that's
Section 3?
Yeah, because that doesn't seem realistic.
Well, that zero people left. Doors.
No,
What do you
but
mean?
Realistically.
Oh my god.
Realistically, what would that be?
What type of line is Section 3?
The like a flat line
Okay, so what does a flat line mean in this context?
where like nobody entered.
Perfect.
But then like what
That's
was
what it means.
happening so that people still entered?
I don't know. People, nobody came
I see what you're saying.
It's just
This is the thing about graphs, right? It's good to question it, but the information is the information. So you could come up with whatever ideas you want as to why nobody entered in that amount of time. The fact of the matter is nobody entered at that amount of time. Okay?
Have you ever seen the Miami Heat game where all their fans
Yes, they left and then the game went into overtime and they weren't let back in. I do remember seeing that. Here's the third page you're gluing in.
Whoa, we got 2 or 3 pages.
Another page.
Another page. Oh no.
There's another one. Players national
Is it posted here? Oh. It's not posted? Good.
I don't.
What a hood.
Alright, let me glue in one more page and I'm ready.
Make sure everyone's got a highlighter too.
Grab me a blue one, is this?
All right, let's just jump right in because we only got 10 minutes. So all the graphs that we've looked at so far are continuous. What do you think it means for a graph to be continuous? It's going on forever. I like that. Tia, did you have an idea? What's that? Basically what he said? Okay. Let me ask you this. Did this line go on forever? Or did it stop at 5 p.m.? Okay, so it doesn't mean it goes on forever. It means that Every point is connected with a line. Doesn't have to be a straight line. Could be a really gross line like this one. Okay? But all the points that we can pick are connected, right? Not every graph that we see in this unit is going to be a continuous graph, okay? Like Gurpreet said, a continuous graph is a graph made up of connected lines or curves. Okay, the opposite of that would be called a discrete graph. Okay, these are not continuous graphs. They are not able, you are not able to connect them with a line, okay? It basically just looks like a bunch of points, okay? And we'll talk about why we can't connect them with this example. So, a student is taking a test, like we all just did on Friday. There are 10 problems on the test. For each problem the student answers correctly, the student received 10 points. 10 problems, 10 points. What's the max score they can get on the test? 100. Okay. This graph represents that relationship. So what's my x-axis represent? Number of problems correct. What's the y-axis? Total points. Okay. So this point right here says that we got one problem correct. And how many points did we get for that one correct problem? 10 points. Okay? So we can get anywhere from 0 to 10 questions, right? Go ahead and highlight this word for me, domain. Did you guys learn about domain before? Give me a thumbs up if you've heard of domain before. Not a domain expansion. Okay, no, not internet relation. Math related. Have you guys heard of domain or no?
No.
Perfect. We're going to talk about it tomorrow. Okay, nope, I already said not like an internet domain. Off to the side. Can you guys stay with me, please, so we can finish before we get out of here? Okay, I'll push the homework off till tomorrow, but you got to stay with me for 8 minutes. Okay? Domain is just a range of x values. Right? So we're going to go into detail tomorrow about domain and range, but for this one, because my x values go from 0 to 10, my range would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Right? There's not 11 questions, so we wouldn't go past 10. You can't have negative questions, right? If the student gets 0 problems correct, the student gets 0 points. If the student gets 10 problems correct, they get, like we said, 100 points. So the range, okay, go ahead and highlight that term, range. That's my set of y values. And I guess I should have not used the term range to describe domain. Okay, set of y values. All right? So the reason why we can't connect all these points with a nice straight line, even though it might be tempting, you see all those points, you see it's linear. Not only is it linear, but it's proportional. You want to connect all those dots. Anyone want to guess why we can't connect the dots? Liana, why can't we connect the dots? In this specific scenario.
Because we can't. What's the scenario?
So it's questions correct and points, right?
Yeah, we can't connect the dots because they can like fluctuate, like they can like change.
Okay, I see what you're saying. You're kind of on the right track. Davis and then Gurpreet. Okay, Gurpreet.
Like, we didn't get the score yet, so like, we can't see how many points they got. So we haven't, so, never mind.
No, I like it. That's a great idea too. Alex?
They could probably get like half the question wrong, so they would get like half the points for this.
So if they get half the questions wrong, they would get half the points. That would be this point right there, right? Now, let me ask you this. In this scenario, can I get half of a question right?
No.
Does it say so in the problem?
No, maybe.
There are 10 problems. For each problem they get correct, they receive 10 points. It doesn't say anything about half credit or half points, okay? If you get it right, you get 10 points. If you get it wrong, you don't get those 10 points. So if I were to have a point right here, right, this point would imply that I got 5.5 questions right.
Yes.
Do you guys see what I'm saying by that? You cannot get 5.5 questions right in this scenario. Okay? So you can also not get 55 points. Okay? Obviously, we're running out of time. So we'll finish this up tomorrow. But a discrete graph like this means there's no middle ground. If we look back here to the plane, there's an infinite number of points in between there if we splice up all the seconds, right?
Whoa.
Yo, what is expansion? Tell me what the